Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on reservoir modeling, reservoir simulation using tNavigator software. And in this series of video, I'm going to show you about how to create and compare cases in tNavigator. Okay, we will use the example dataset from tNavigator, so hopefully we can learn a lot in this series of video. Okay, so first I'm going to import the model from a dataset. All right, dataset for simplicity, just if you have the file called or with the extension of .dat, that's the dataset. Okay, I want to convert, I want to import the existing model from that. And here we have two options: convert schedule section to well rules, which is recommended, or import model without schedule section conversion. Now I'm going to select this one. So the calculation results may differ from the case without conversion due to model complexity. Okay, so click on OK. All right, let's wait it for a while. Okay, so this is our model. Let's go to it first, go to 3D grids, and then here we select this current model, black oil. And then this is 2D map. You can also switch to 3D map. Okay, right click here, adjust size by data. Okay, so I'm going to show you first the important grid called Eng-Man. So here we have two regions, the brown color and the green color. Go to grid, open the drop-down menu and touch this one and show palette. So you have Eng-Man of 0 and Eng-Man of 1. Actually, Eng-Man of 0 is for the grids that will be inactive. Okay, this is still a static model. So after you initialize the model, the inactive grid blocks will be neglected. Will be neglected. It will not be used in the computation during the dynamic model. Okay, so you get this from the geomodeler. As reservoir simulator, we just receive and we initialize the model and we focus all the computation, all the simulation on these grid blocks that are active. Okay, and others, of course, the porosity, net to gross, permeability along X, Y, Z, saturation region, we only have one, PVT region, we have two. Okay, and then this is for the equilibration zone. All right, this is fluid in place separated by the fault. This is still static model, so this is not our domain here. Okay, our domain is after we initialize the model, change it to the dynamic model. Fluid in place number. Okay, and we can also check the fluid properties, the raw compressibility, and this is for the initialization, the equilibrium data, and then this RS, solution gas ratio versus step, relative permeability package, Lefebvre J function, okay, and then endpoint scaling method, stone three-phase oil relative permeability, equilibration data, okay, and then bubble point, and this is for the raw compressibility. So we will use this one, import fluid properties, black oil. Everything here is taken from the dataset, okay, and then wells data here, well, the ID of the well, the date, the event, perforation, top and bottom, inside, and so on and so forth, and inside diameter, skin, multiplier, and so on and so forth. Okay, so that's for the introduction. Now, let's initialize the model and change it to a dynamic model, shall we? Okay, so let's go to Eng-Man here, and you will see what happened after we initialize the model. Okay, so initialize dynamic model. You must save project before continuing. Save project. All right, and let's wait for a while. Create result. Okay, let's call it result 1 for simplicity. Still initializing. All right, so after initialization, this is what happened. You see, we only focus or we only honor the grid blocks that are active. All the grid blocks with ACNUM of 0 are deactivated and will be neglected. Now we are in, so the software will produce a new set of grids, set of 3D grids. Now it's called dynamic model.